Have you ever been interested in server administration? If so, this course is for you. In today's world, it's practically impossible to operate any size business without having at least one server. These days, servers come in a variety of shapes and sizes. Small businesses might have a single computer acting as a server sitting in a closet somewhere, whereas a larger organization might have the need for racks and racks of servers in a specialized room that is designed for those servers. Heck, there's even the possibility of using virtualized servers or getting your server-based services in the cloud. My name is Ed Lieberman, and I've been teaching people about servers and related IT systems since the 1990s. So please join me in my LinkedIn Learning course on Networking Foundations servers. Before watching this course, there is exactly one thing that you need to know, and that is that this course was designed for everybody. I designed this foundations course in a way that pretty much anybody who's interested in getting involved with server administration should be able to follow along. Now, I do want to tell you that most of this course is concept based, but there are a few demonstrations where I actually go into a server and show you how to do something. I'd like to point out that while there are many different types of servers out there, all of those demonstrations will be done on Microsoft Windows Server 2019. And again, they're going to be done at a high conceptual level. I do want you to know that there are a number of courses in our library that you can also go to if you want to get more detail. Now, I'd also like to point out that because I'm doing everything in the world of Microsoft Server, that one of the other major vendors out there is Linux. And we also have Linux courses that can show you how to do everything I'm going to talk about in this course in the world of Linux. And I want to just give you a few basics. So just give you a starting point of where you can go to learn the Linux side of things. The first would be learning Ubuntu Server, which covers standing up a bare metal server and some basics in networking. Again, a couple things I will show you here in this course in the world of Microsoft. We also have a course called Linux Network Configuration, which will just go through the manual configuration of the networking in the world of Linux. And we have Linux storage systems, which will talk about disks, partitions, file systems, RAID, permissions, security, and things like that. Those are just a few courses that I may reference as I'm going through the course for you to maybe go back and see how things work in the world of Linux, if that's what you're trying to accomplish. The term form factor when it comes to computers refers to the size, shape, and the overall packaging of the computer device itself. Now, servers typically come in one of three different form factors. The first is what's called the tower server. Now, this particular type of server probably isn't that unfamiliar to you or really most people because it is very similar to your typical desktop tower computer. It's still the same kind of large rectangular box that is designed to hold all the various components for the computer. You want to keep in mind that the one big issue with having a tower server is that it takes up a lot of space. And so it's typically only going to be found in a smaller company that requires fewer servers. Now, one big difference that I do want you to understand, especially if you're going to attempt, let's say, to build your own server, is that you want to look for special server features in a tower that's built for a server. A couple of these features would be redundant power supplies, because your servers are very important. So a power supply fails, you don't want the server to fail with it. And the ability to have hot swappable components so that you can trade things out without having to shut down the computer. The second form factor that we'll find in our servers are rack mount servers. Now, I mentioned with the tower servers, we really can only have a small number for it to make sense. Well, the idea behind a rack mount server is that it is designed to save space. Okay, we end up having these servers which are thin and wide, and they slide in and out of a rack cabinet. All right, now these racks are typically 19 inches wide. That's a very standard width that you'll find with these. And the height of both the individual servers and the actual rack itself is measured using something called rack units. Now, one unit is equal to approximately 1.75 inches in height. And your rack mount servers, you very typically find them to be rated somewhere in the 1U to 4U, okay, which stands for 1 unit, which would be 1.75 inches high, to 4U, okay, which if you just do the math, that would be about 7 inches high. So you don't want to get much bigger than that, but sometimes they are. This is what you're going to find when you're looking at your rack mount servers. Now, one thing you really have to keep in mind with these rack mount servers is even though they are designed to hold more servers in an enclosed space than you'd have with your tower servers, well, each server still is kind of an independent machine. And so each one's going to have a lot of independent cables coming out of the back. And so we have to use these cable management arms so that when you're sliding these rack servers in and out, the cables are guided appropriately. But keep in mind, if you ever look at the back of a rack mount server rack, you're going to see a lot of cables. Well, that leads us into the third form factor, the use of blade technology or your blade servers. And this is the technology you would use for the largest number of servers housed in the smallest location. Now, why is this? Well, first of all, these blades are very thin because the server, the entire server, is actually contained on a single card, and then that card is mounted alongside other blade servers, right? So you have a whole bunch of these blade servers all together in a single blade chassis. Now let's talk about this blade chassis, or we'll call it blade enclosure. I mentioned with the rack mount servers all the cables. Well, here with the blade technology, we have a single power supply, a built-in KVM, which stands for keyboard video mouse. Okay, so it's just one single keyboard, one monitor, and one mouse that controls all these different cards or these different blade servers. And therefore, you put all that together, you end up with minimal cables. Okay, so you can have a very neat and organized system with a lot of server power. All right, so those are the three primary form factors that you'll find with your servers. And so now you know what kind you're going to want to get based upon the needs of your organization. Now, as a server administrator, you typically won't be, at least not on a daily basis, actually having to service the insides of the servers. You're mostly responsible for administrating or running the servers, but you should be familiar with the components that are inside the box that truly make up the server. You may be involved in the purchasing of some of these components, and you also may want to be able to just have an educated conversation with a computer technician who's working on your server. So let's take a look at some of these. First, can't really talk about anything without talking about the motherboard. And the motherboard is the main circuit board that provides communication to all other components. This really is the heart of everything, okay? Everything flows through the motherboard. And in fact, almost all the rest of the components we're going to talk about, well, can be found on this motherboard or connected to it. So the next component here we'll talk about is the CPU, or what's commonly known as the processor. Now, there's many different factors that go into the processor in a particular server. One would be the socket type. And even though processors in today's world are pretty close to the same shape and almost same size, the reality is that there's a variety of sockets that the various motherboards have. So you have to have a matching socket type. Now you want to make sure that you get a processor with an appropriate speed to handle the workload. In fact, many mother server boards are equipped to be able to install multiple processors to help with that speed. The processor will have a cache. Okay, it's what's known as its L1, L2, or L3 cache, which is a very small amount of very high-speed memory, which helps with the communications of data in and out of the processor. And then we have the architecture, which is known as either x86, which is a 32-bit processor, x64, which is a 64-bit processor, and then we have ARM, which is a very low-end, low power consumption processor that you never would find in a server. I just want to mention it if we're going to talk about processors. This is what you would find on a smaller device like a smartphone or a tablet. All right, now in your servers in today's world, we're typically only looking at our 64-bit processors. Next, we have RAM, which stands for Random Access Memory, or many people just know it as the memory of a computer. It's also known as volatile memory. Okay, it's temporary memory, which means that when the server shuts down, you lose anything that's in that memory, as opposed to permanent memory, which would be like the hard drive. All right, now when you are purchasing memory, there's a few things you want to pay attention to. There's a lot of different technologies that are out there. Some of the basics are knowing whether you want your memory to be ECC or non-ECC. ECC stands for Error Correction Code, okay, which is the technology used to detect and fix errors. You want to know that there's many different versions of DDR memory that's out there, okay? We have DDR versions 1 through 4, and at the time that I'm recording this, in fact, we are right on the edge of DDR5. Okay, so most of today's server memories are going to be probably DDR3 or 4. Okay, but like I said, 5 is right around the corner. And then understand, similar to the socket type that we talked about with the processor, you want to pay attention to the size of the memory as far as the physical size and the number of pins to make sure it fits into your motherboard. And then we have some expansion slots on our motherboard. Okay, some of your typical expansion slots might be PCI or PCI Express, or there's even another one called PCI Extended. All right, a lot of PCIs out there. We also have AGP for our graphics card. But the one other type of expansion I want to talk to you about when it comes to servers is something called a riser card. And the idea behind a riser card is many servers are very thin in nature. And the expansion cards that would go into these expansion slots are too big to fit perpendicular to the motherboard and still fit in the box. So the idea behind a riser card is a very low profile card that is designed to then sit perpendicular, slide into those slots, and then give you one or two slots that you can then have your expansion cards go parallel or even with the motherboard so that it would fit. And then we have our various interface ports. Okay, so this is how we can have connectivity with our peripherals. We might have network connectivity or a monitor or maybe USB connectivity. And then we have our hard drives. I mentioned this before. This is more permanent memory or non-volatile memory. Okay, the old-fashioned hard drives would be magnetic, okay, which is where we use disk platters and they actually spin around and use read-write heads and everything else. And in today's world, really what we want to have in our server systems are solid-state drives, which have no moving parts and are much faster and quieter and give much better performance. Now, before I wrap things up, I do want to mention one very specific thing. I talked about this actually in the previous video. Use the term hot swappable. Okay, a hot swappable component is a component that can be changed without shutting down the server. Okay, so that's very important to know that when dealing with components in a server, you really want to try to have a hot swappable environment so that you don't have to shut down the server, since servers play such a vital role in your organization, in order to swap out components when they've gone bad or if you want to just simply upgrade. So that's what hot swappable is. And those are the basic components you'll find in all computer systems, including your servers. Computers of any kind, including your servers, need some form of power in order to operate. But in order to give them power, that also means that you're going to generate heat. All right, and so anytime we're going to talk about power, we have to also talk about cooling so that we can prevent our systems from overheating. So first, let's talk about power. And when we say power, we really mean, well, electricity. And there are 3 electrical terms that you should be familiar with when evaluating power for your server. The first is voltage, which stands for the force of electricity. And then we have amperage, which has to do with the flow or the current of the electricity. And if you take that force or voltage and multiply it against the current or amperage, you end up with the term that's probably most important to you as a server administrator, which is wattage, which is the actual measurement of electrical usage. All right, now why is this important? Well, it's important because when you are deciding what kind of power you're going to provide for your servers, well, you need to take overall consumption into consideration, right? You need to look at all the different components that are in your server and determine how much power they're all going to need or consume, and then get yourself a power supply that's large enough to provide all of that electricity. Now, another thing to take into consideration is redundancy. Because we're talking about servers here, we want to make them reliable and highly available, right? You don't want your servers to go down. So you want to consider getting power supplies that are larger than just the basic needs that you have, right? So that way you know that no matter what, you've got all your power needs met. And maybe even have multiple power supplies, each of which on its own could run the server, so that if one was to fail, your server is still up and running. Now, as I mentioned, you can't talk about power without talking about cooling, right? Because there's going to be heat generated with all of this electricity. Now, when we talk about cooling, the main thing to keep into consideration has to do with airflow. All right. Now, just to be clear, I'm talking about in the server itself. Yes, we can talk about the environment and the server room itself, and we'll talk about that a little bit later in the course. But here I'm talking about in the actual server box itself. The servers are designed, the cases are designed to have air flowing through the box in a way that components are kept cool. And I want to tell you about one huge misconception so you don't make this mistake. A lot of people think that if you have a system that is overheating, that you can just take the cover off and open up the computer, and that will help keep it cool. But the fact of the matter is it'll have the opposite effect. And the reason why is because you'll lose your airflow. Because you have more air doesn't mean it's cooler air. So what do? How do we actually use this airflow? Well, one of the things we have is thermal dissipation. Okay, so let's take like a processor, for instance, which will have a heat sink on it, which is specifically designed to pull heat away from the processor. And we'll also very often have baffles and shrouds so that when you have the air flowing, it's deflected in a certain way so that as the heat is pulled away from the processor, it then is deflected in the right direction. And by the way, how do we get air flowing in that direction? Well, it's done through the use of fans. Okay, very often the cases themselves will have fans. The processor may have its own fan. Okay, there's many different fans which will keep the air flowing through the entire system. Now, the other way that we keep our systems cool in today's environment is through liquid cooling, okay, where you actually have a bunch of tubes basically that have liquid that are flowing through them, so that will help move the heat around the system and get it away from the components as they are warming up so as to keep them from overheating. Again, very basic here. Power 101, got to know the basics. Make sure you know how to buy the right power supply. And then you want to make sure if you do get into your system that you know how to keep things cool properly. So what exactly is it that makes a computer be a server? When you are looking to buy a server, you may find vendors who are saying, oh, buy this server computer. Well, that just means that it's computer hardware that is designed for a server operating system to be installed on it and to operate as a server. And in fact, you could get that operating system installed as part of the purchase of the computer itself. But if you didn't and you want to install your own, you should know how to do it. Now, as I mentioned at the beginning of the course, There are many different server operating system choices that are out there, and I'm going to demonstrate how to install Windows Server 2019. So here on the screen, we are looking at my Hyper-V manager. We'll talk about virtualization later, but I have a virtual machine that's created. It's just called Windows Server. And I'm going to go into it, and you'll see that this machine is off and is a bare metal machine, meaning it's as though I just bought a computer and it has nothing on it. It's just brand new. Nothing's been installed. The only thing I've done to this machine, just so you know, is I've emulated, because this is virtualization, I've emulated that I've put a Server 2019 DVD into a DVD drive, okay? So I'm going to go ahead and click on Start. Now, this is going to happen very quickly. It says press any key, and I press the key on the keyboard, and that's how I boot into the actual DVD on this virtual machine. All right, now I apologize. The resolution is going to get a little weird here because it's a virtual machine, but you can see here it takes me into the Windows setup window. So here's Windows Server 2019. I need to pick what language, time and currency format, and keyboard or input method. And so because I'm in the US and speak English, I'm going to take all the defaults and click Next. And then it jumps right into a button that says Install Now. So I'll click that button. Now, I will mention while we're waiting here for just a moment that what you're going to find is that while I happen to be going step by step through this to show you how to install Windows Server 2019, Microsoft and pretty much every vendor out there has made this so super simple to be able to go ahead and do. All right, so here you can see here that it's asking me what version I want to do. And I want you to notice that it says evaluation. This is an evaluation copy. And I did this specifically because you also may not have an actual licensed copy. If you want to follow along, you can download the evaluation copy. You have a choice between either standard or data center, and you have it with the desktop experience or without the desktop experience. Well, let's go for the full thing. I'm going to select data center with desktop experience. So that's everything. So I'll click on Next. Here I get the license terms, so you can read through it if you like, but most importantly, you need to check a box saying you accept the license terms. All vendors will have some form of license terms, so I'll click Next. I need to choose what kind of installation it is. If I was upgrading from a previous version, I could click Upgrade, but I'm not. It's a new install, so it's actually custom, so I will click on that. I need to select what hard drive I want to put it on. I have a 200 gig hard drive that's been created here. I will go ahead and use the whole hard drive, so I will click Next. And it begins the installation process. Now, I will tell you that this process does take some time. And so through the magic of editing, I'm going to actually speed this along. So if you're following along and doing this with me, go ahead and pause the recording and then resume when this process finishes. And I will warn you, by the way, it will involve a reboot or two. Okay, so my system has finished installing and has rebooted. And here we are sitting at a customized settings screen where it basically says you need to set up a password for the first built-in account, right? You have to have at least this one account, and that's the administrator account. So I'm going to go ahead and put in a super secure secret password here. And you got to put it in twice, make sure it matches. And you can't really see it because, like I said, my screen, the resolution is a little wonky until it's done installing. But if I scroll down a little bit, there is a finish button. So I'm going to click on Finish, and it finalizes my settings. This is where I actually can fix the resolution. This is just a virtualization thing. And connect. And now it jumps to a full screen here. And I have my administrator account, so I will put in my super secure password once again. And enter that. And at this point, the operating system has been installed. And now I'm just logging in for the first time. And in the case of Windows Server 2019, what's going to happen is, other than this network question that comes up, I'll just click yes to that and just ignore that. It takes you into the Server Manager, which is something we'll talk about in another video. So that's how you install Windows Server 2019. Part of the installation of a server operating system is to give the server an initial basic configuration. You know, things like a name for the server or an address on the network and things of that nature. Now, some vendors will possibly have you do it as part of the initial installation, and some have you do it as part of a
somewhat of a post-installation task, so to speak. So again, I'm demonstrating here on Windows Server 2019. If you want to see it in the world of Linux, again, please go back to the beginning of this course where I referenced a number of courses where you can see how this is done in the world of Linux. But here on Windows Server 2019, it is done as part of a post-installation task. What we're looking at on the screen is our newly installed Windows Server 2019 computer, and it opens by default into this thing called the Server Manager. And in the Server Manager, you'll notice that right near the top, under Quick Start, it says Configure this local server. Well, this comes in real handy because when I click on this link, it takes me into a window where I have links to do all the different basic installation steps that I may care to do. So for instance, right up here at the top, you'll see here it gives a random computer name. Well, I don't want that. I want to actually name this server. And it's part of a work group, whereas if maybe this server was going to be part of a domain, I could make it part of a domain. There's some things here about Windows Defender Firewall, and then over on the right, Windows Defender Antivirus. We have some remote management and desktop capabilities, NIC teaming if I had multiple network cards. Here's a big one, Ethernet. Here's where you set up your IP address. In the upper right, there's some information here about updates. So this has to do with security updates, right? So Windows updates. You'll see here it's never been done and how it's configured to do it. And then how about time zone and the Windows activation? All right, these are all things, and they're all links. You'll notice that when I hover the cursor over it, it kind of highlights like it's a link, okay? So again, this is going to be slightly different depending on what operating environment you're in, but I will do a kind of a quick demonstration of a couple things here. One, let's change this computer name. So all I have to do is click on this computer name here, and it takes me into my System Properties window. And in this window, you'll see here, it gives my name and work group, and I click on Change. So let's give the computer a new name. We'll call it Demo-Server, just to give it a name. If I was going to join a domain, I would click on Domain and then put in the name of the domain that I was going to join. In this case, I don't have any other computers running on my network, so there's no domain for me to join, so I'm going to leave it as part of a work group. So I'm just going to change the computer name, click OK, and it's going to tell me that I have to reboot in order for this to happen, so I'll click OK to that. When I go to close this window, again, it says you must restart. Do you want to do it now? And I'll click Restart Now. I will tell you, again, this takes a few moments, so if you're following along, go ahead and pause the recording and resume once we have rebooted. Okay, you can see here my system has rebooted. It's waiting for me to log in, so I'll put in my administrator password. And when I log in, you'll see here that automatically it's going to take me right back into the Server Manager. It'll do this every time. In the world of Windows Server, it takes you right back into the Server Manager every time. Now, don't worry about these little red boxes that popped up, especially on your end. Same thing. This is normal. These are just delayed services. So they'll just temporarily be red and then they'll go and then they'll be fine. So I'm going to go back to configure this local server, and you'll notice that the computer name is now Demo Server. So what else can we do? How about the IP address? That's another real basic thing that every machine must do. Right now, it's getting it via DHCP, but as a server, usually we would want to have it be, statically assigned. So if I click on it, it takes me to my network connections. Here's my Ethernet connection, and I would need to right click and select Properties. And then here in this Properties window, I'm going to highlight IP version 4 and click on Properties again. And you'll see here it's obtaining an IP address automatically. If I wanted to do it statically, use the following IP address and then type in my IP address. Now again, I'm not setting up any kind of a super sophisticated network here, so I'm going to cancel out of everything. I just wanted to show you that's how you would do it. All right, and then everything else you see in this window would work the exact same way. And when I'm done, I would just go back to my dashboard and move on to the next step. All right, so that's how you do your initial post-installation configuration in Windows Server 2019. Once the server operating system has been installed and you've gone through some basic initial configuration, the next thing you need to do is you have to determine what the actual purpose or role for this server is going to be. So any given server has a number of different roles that it could play in your network. All right. And again, this is going to be slightly different depending on what operating system vendor you're going with, but the concept is the same. All right. So if we know that this server is going to be a web server, well, then we have to configure it for being a web server. If we know that this server is going to be a DNS server or a name server, well, then we have to configure it to be a name server. If this server is going to be a domain controller, well, then we have to configure it to be a domain controller. And by the way, it is possible for a single server to be multiple roles. That is something that can be done. All right, so again, let me just show you some basics here in the world of Windows Server 2019. Here in the Server Manager, we already did step 1, which was configure this local server, which was the basic initial configuration. And now we go on to number 2, which says add roles and features. So I'm going to click on that, and you'll see here that it takes me into a nifty little wizard to make this easy for me to do the configuration based upon the role that I choose for this particular server. Now, this first window that comes up, which very often people will check this box saying skip by default, before you begin, it's basically saying, hey, now that you're going to configure this server to truly be a specific role, to do something important, it's important that you have certain things in place. And you'll see there's these 3 main bullet points. It says the administrator account should have a strong password, your network settings should be configured, and you should have the latest and greatest security updates. Okay, so those are things that are important. These are things that have not been set up properly on this machine because this is just a demonstration machine. But in the real world, those are very important steps. So let me go ahead and click on next. So we're going to say that we want to do a role or feature-based installation. Click on next. What server do we want to install on? We want to do it on demo server, the one we're on right now. And the reason for this is because in the world of Microsoft Windows Server 2019, I could, from this machine, I could manage other servers from this machine. I only have the one server though. So I'll click on next. And then this is where you can choose the different roles. And you'll notice there's a fairly lengthy list here of roles. For instance, there's a number of these Active Directory roles. If I wanted to be a domain controller, then the role that I would want is Active Directory Domain Services. And by the way, in the world of Microsoft, when you click to highlight one of the names over on the right, you will get a description that tells you what the role is. If I wanted to be a server that hands out network configuration to other machines on my network, I could be a DHCP server. If I want to be a name server, I could be a DNS server. Scrolling down here a little bit, here's Hyper-V. If I wanted to be a virtualization host, okay, which is kind of weird because, yes, I know I'm actually on a virtual machine right now. But the way my physical machine was set up, it was set up with Hyper-V on it, okay, just to give you an example. Or let's say I want to be a web server. Okay, we have our web server or IIS, Internet Information Services server. Okay, so just to pick one, just to show you, I'm going to actually check the box next to DNS server. And you'll notice that it automatically helps me out and says, hey, you know what? If you want to have that role, well, then you need these other features that are also part of it. And I say, great. Go ahead and add those features as well. And you'll notice here, because I told you that I have not configured this machine properly, it says, uh-oh, we have a problem because I don't have a static IP address assigned because I never went through that step. I intentionally wanted you to see this error as opposed to just having a perfect setup go through to show you that in the world of Microsoft, this stuff is going to kind of assist you along the way. And by the way, in today's world, no matter what operating system vendor you're working with, they all do this. So I will click continue, and then I'll have to go ahead and cancel out because without going through the rest of the proper setup of this server, I'm not going to be able to go the rest of the way. But I will tell you, there were only a couple more clicks, just a couple more like next, finish, and it would have installed everything for me. All right, so the main thing is understanding the idea of you have to go ahead and decide what is this server going to be, and then go ahead and configure that role for that server. So let's talk a little bit about being able to actually administrate our servers. Well, first thing I want you to keep in mind is when it comes to actual local hardware administration, like you physically want to go to the server and administrate it, well, it's not quite as basic as it may sound, all right? And especially in your larger server room environments, right? Meaning your local desktop computer, no big deal, right? You just sit down and there you have, your keyboard and your mouse and your monitor, and push a button that says, I want to manage this particular server. And then it connects the keyboard, the monitor, and the mouse to that server. Now, beyond that, I will tell you, there is another way to physically get in and manage a server. This is completely out of date. Okay, I want to be very clear about this. I can't remember the last time I saw this done, but just in case, because there are some old systems out there, if you find yourself in this environment, there is serial cable connectivity with some of your older servers. And the idea is actually pretty simple. It's the idea that you walk in with, say, a laptop, and with a good old-fashioned serial cable, you connect the laptop to the server, and then you manage that server by using the laptop. And then we have the idea of virtualization that we need to have into consideration. Now, I'm going to talk about virtualization in more detail later on, but the idea is understanding that with virtualization, you can have many servers, or what's known as virtual servers, that are all contained on one physical server. So it's a matter of sitting down at the one physical server to be able to administrate all the virtual servers that are hosted on it. Now, next, let's talk about network-based hardware administration. First, we have this thing called KVM over IP. Okay, so you can probably imagine the idea of having a KVM switch box, but it's connected over the network. Okay, so that's kind of a cool way to be able to connect to various servers with a single keyboard, monitor, and mouse. And then we have something called ILO, all right, which stands for Integrated Lights Out. Now, this is a technology that is embedded specifically into HP or Hewlett-Packard servers, and allows for out-of-band management of the server. Now, out-of-band management refers to any method of managing the server that does not use the network. Okay, it's a physical connection with an Ethernet port that'll be on the server itself. And then we also have IDRAC, which is Dell's version of the exact same technology. I mean, let me tell you, if it were up to me, I would never even want to walk into a server room, right? Just don't even want to be in that server room at all. So let's talk a little bit about remote administration, right? I want to go ahead and sit at the comfort of my own desk. And we can do this through a technology called the Remote Desktop Protocol, which, in the old days, I'll tell you what, if this was 10, 15 years ago, I'd be talking to you about Remote Desktop Protocol, and it was this brand new thing, and it was really, really spectacular, where it was like you literally would see the screen of the server out on your desktop. Now it's much more advanced to where we're literally just remote administrating the server while being able to do so with the tools from your own desk. Now, if you don't need to see the graphical interface, you can remote administrate through many command line tools. And one of those tools is actually Secure Shell, SSH, okay, which is really a secure way to go ahead and remotely manage via a command line. So these are just some of the methods on how you can actually get in and administrate your servers. Once you have everything installed and configured on your server, the next thing is to make sure that you know what tools are available to help you manage and maintain that server. Now, I will tell you that every operating system vendor has their own built-in tools to help you manage that particular operating system. And then there are also some third-party tools which can really get very detailed on the management that's available on your server systems. So again, I've said this before, and you are welcome to go, start researching and looking if there's something specific you want to see in detail. There's plenty of courses we have in our library which will go into the detail on some of these tools. But I would like to just take a few minutes to go through kind of a high-level overview of the general types of tools that are available. So for instance, here in Windows Server 2019, we have our Server Manager, right? It's the tool that opens by default. It's the tool that we've been looking at here. And here in this tool, we already have done a couple things, right? We use this tool to configure the server and even see how we could configure it for specific roles. We also have the ability with this particular tool to manage multiple servers, right? We can add other servers and manage it right from here and even put those servers into a group. Down at the bottom, we have these boxes where they show us if there is any kind of alert going on. If you're following along, if you're using it, you notice when you first boot a Windows Server 2019 computer, these boxes will turn red because there are certain services which are delayed start. And you can do a whole lot from this tool. So not only can you see where you have certain alerts, you can also manage the specific services. So for instance, this is a file and storage server. So over on the left, I have the ability to go in and do some management specific to file and storage services. In the top right, you'll see I have some menus where you can see here if I click on manage, this is another way that I can do some of the things that I was clicking on over here. If I click on tools, this is where I can access many of the different tools that are available on this server. So that's just kind of an idea of a general server management tool. And all servers have some kind of, that central hub where you can do management for that server. Now, one other generic tool that I'd like to show you is the Task Manager. And if you've worked with any Windows machine, going all the way back to, I believe, Windows 95, you might have seen this Task Manager. So if I right-click down on the task bar at the bottom and then select Task Manager on that menu, you'll see here I get a very, very basic tool here. All it shows me is I have one task running, and that is the Server Manager. And if I were to highlight it, I could click End Task, and that would then close the Server Manager. But believe it or not, this tool actually can do a whole lot more. If I expand more details, you'll see here that now I have all kinds of processes that are running. I have the Server Manager, I have the Task Manager itself, as well as a number of background processes and Windows processes that are running. So I have all kinds of processes that are running here. We have a Performance tab where we can look at a little bit of performance. We can look at our users. I only have the one user, administrator. Go into some other details, and we can even look at our specific services. We can do all this right from the Task Manager. So again, a very, very basic tool which will help you with specific task management capabilities in a Windows Server computer. That's just kind of the general idea of understanding where you can get some server management from in your particular server. One very specific aspect of server management has to do with keeping track of how well that server is performing. So again, there are many different performance monitoring tools out there, but let me just kind of show you some of the performance management capabilities that you have in Windows Server. If I go back to my Task Manager, which we were just looking at in the last video, so I'll right click on the taskbar, go back to Task Manager. One of the tabs at the top is the Performance tab. So I'll click on that. And let me tell you, when it comes to performance on any computer, there are many, many, many different aspects of performance, but everything always breaks down into 4 general areas of performance. And we can see 3 of them here. There's always the processor, which that's what I'm seeing here with CPU. There's memory. There's your network. And the 4th one, which we don't get to see here, is disk performance. Now, what you're seeing here is you're just seeing a 60-second or a 1-minute snapshot of how things are performing on this machine right now. Okay, very basic, cannot do a lot with it other than if you know that the server seems to be heavily tasked or it's really, really slow, you might want to come here and just quickly go, well, how's my processor doing? It looks good. How's my memory doing? Oh, it looks good. How's my networking doing? Okay, just kind of look real quick just to see a snapshot of what's it look like right now. Now, if you want to get into a little bit more detail than just this generic snapshot that we have here, down at the bottom of the Task Manager, it says here, Open Resource Monitor. That's another tool we have available. Okay, and here in the Resource Monitor, you'll see here on the right, we get all 4 areas of performance that I mentioned, right? You get your processor, you do have your disk management or performance management, and your network performance and your memory performance. And over on the left, you'll see here that we can get into detail as to what's using up the processor, what's using up the disk, what's using up the network. And if I scroll down a bit, what's using up my memory. All right, so I can get into much more detail. And in fact, I can even click on a specific tab for CPU, memory, disk, and network. And again, I can get into much more detail into what is tying up my processor. Okay, so again, I'm not going to go into any great detail other than show you that this is a great tool to get very detailed information about what is using up the resources on the server. So let me close that, and I'll close the Task Manager as well. Back here in the Server Manager, I do want to show you, if I go up to the Tools menu, I also could have gotten to the Resource Monitor that way. Okay, we were just already in the Task Manager, so I figured we'd go from there first. Now, there is one more tool that Microsoft builds in, and it's a great tool. It's probably the best one when it comes to performance monitoring, and that is a tool called Performance Monitor. If I click on it, here in the Performance Monitor, again, I can see a snapshot. It's actually a minute and 40 seconds of what's going on. Right now, it's only one, what's called a counter that we're looking at, and that's percent processor time. If I right click, I could add additional counters. So if I wanted to look at some other aspect of the processor or something with memory or disk or network, I could add it here. But again, it's just a snapshot. You might be thinking to yourself, wow, all these tools just showing a snapshot of what's going on right now. The one thing that's really, really cool about this particular tool is that over on the left, you'll see we have data collector sets and reports. And that's where you can go in and you can capture historical data. Now, you can't go back in time, but you can schedule it, and then you can hold on to that data and run reports on that data. And this is a really good idea when it comes to performance monitoring, because what you want to do is you want to look over time. How is it performing today? And then maybe how is it performing a week from now or a month from now? And you look for a trend. If the performance is getting weaker and weaker and weaker, that could be a sign of a problem. All right, so again, idea is not necessarily to teach you the specific tools. Want to make sure you understand the tools exist. And performance monitoring is a very important management component to keep track of. One of the most important tools to be familiar with as a server administrator is any form of event logging tool. These tools should be your absolute best friend as a server administrator. These are the tools that are truly going to tell you what is and has been going on with your server. So, in the world of Microsoft, here on our Windows Server 2019 computer, the tool that we have available is called Event Viewer. The way we get to it is here in the Server Manager. I'm going to go up to the Tools menu, and you'll see here I have an option for Event Viewer. So I'm going to click on that, and then I'm going to expand my Windows logs, and I'm going to click on the System log. Now, there's a lot of things we could be looking at here, but basically I want you to see here that I'm kind of scrolling, and you can tell I'm scrolling because now you're starting to see different colored things coming through as far as errors and warnings. And the main point here is that there is plenty of things that are happening. I mean, I've only had this machine going for probably like an hour, and there is quite the log here going on. All right, so what I want you to know about this particular log is that it's logging everything. Like everything that's happening on this machine is being logged. And if you see an information entry, it means just that. It means something happened. I'm just logging it, just let you know something happened. But if I scroll down and I see here that I have a warning means something happened that didn't seem right, but we're not actually seeing anything fail because of it. We're just saying, hey, this might be worth looking into because something's kind of out of whack here, even though we're not actually seeing anything truly failing because of it. But then we have these red errors. Those are the bad ones. Those are the ones you got to look out for, because that means something bad is happening and we are seeing a failure because of it. Now you'll notice here, it says here both the warning and the error are both because of the time service. And this is not uncommon, by the way, on my virtual machines that I set up when I'm creating these courses, because this is just a demo machine which I have not taken the time to go through and configure properly. And so the time service is out of whack. And so it gave me a warning saying, all right, this is a problem. And then it follows up with an error. It says, okay, now something really bad has happened. All right. And if you click on it, you can actually see here, to say the time service has detected the system time needs to be changed by, I don't know how to calculate how many seconds that is. Probably because it looks like this date is off on my machine by about a week to a week and a half or so. So if I did the math, that's probably what it comes to. And it also gives you more information here that would help you to possibly go online and look up, for some of these errors that could happen. So again, that is what should be your absolute best friend. If somebody says something's not working right, or if you're noticing something's not working right, the first place you should go is to the event logging tool. In the case of Microsoft, it's the event viewer. In fact, I once knew a guy who he religiously, every morning, the first thing he did when he showed up to work was he went through and he read through all the different events from the last 24 hours so that he would know what's going on with his systems. And let me tell you, he was a fantastic administrator. He always found problems before users were complaining about them. All right. So that event logging is something that you really should pay a lot of attention to if you want to be a server administrator. So now let's talk a little bit about something that is unfortunately overlooked more often than it should be. And that is a form of documentation called asset management. All right, you want to make sure that you have good records of all of the assets within your organization. So what is some of this? Well, first we have licensing. Okay, so when you have to understand that when you purchase software, what you're doing is you're purchasing a license to use that software. And it's something that you should keep track of, right? You shouldn't just buy the software and then use it, because it is possible that your organization can be contacted by a software vendor or can be audited if somebody suspects that maybe you are pirating some of that software. So you want to have those licenses available to be able to show that you are doing things legitimately. Next is labeling of your assets, right? Just simply taking your servers and your workstations and having them all labeled with any aspect of that particular server, let's say, and what we need to know about it. Okay, so all the different things that we'll talk about. So the license could be one example, having a good label of the licenses of what's being used on that server, along with other things. Matter of fact, I'll segue right here into another thing, which is the warranty. Okay, very often the label can include purchase date, which may tell you how long, that particular asset will be under warranty. Okay, these are things that you want to keep track of. I'm sure you can imagine as I'm talking to you about this, about how this stuff seems so simple, but yet at the same time, we ignore it until we need it and then we can't find it. Now, a couple of things I'm going to go into in more detail has to do with life cycle management, okay, which has to do with the actual acquisition, usage, and disposal of your assets, and then keeping an actual inventory itself. So let's talk about this life cycle management. All right, you want to have an actual management of the life cycle of the equipment within your organization. Okay, again, smaller organizations tend to just kind of use what I like to call by the seat of their pants method, which is, they just go ahead and get equipment when they need it, right? And that's it. Well, the reality is that you should have an actual life cycle in place, even in a small organization. And this cycle starts with procurement, okay, which is the idea of actually acquiring the asset, acquiring the server itself. how that particular server is going to be used, deciding, well, when's the end of life? How long do we want to use this server? And again, smaller organizations sometimes can get away with just saying, well, we'll use it till it dies. But that's not really the best way to approach this, because you'll find yourself in a jam when it dies, maybe when, like the worst possible time. That's what tends to happen, right? So you want to go ahead and plan for an end of life for a server before it actually dies. And when the server does finally get to the point that's no longer being used, you also then have to decide how exactly it's going to be disposed of, so that you are securely disposing it and being environmentally friendly. And then when it comes to inventory, basically you want to have a good inventory of all of your assets, right? That's probably what you were first thinking of when I said asset management, which is just an idea of, for every asset you have, you want to know the make and model. You should have the serial number, right? These are real basics for any component you have. And all of this information, if I just kind of want to reel us back into something I mentioned a few minutes ago, which is labeling, this stuff can all be on an asset tag, which is part of the labeling on the server, so that you have all the information in one place. Even though it may not seem important in a smaller organization, asset management is very important. Make sure that you're doing it. And speaking of things that are not a whole lot of fun for most IT administrators, how about just some general documentation, right? We were just talking about asset management and how, it's something that's very often overlooked. And the reason why is because of the documentation aspect of it. Documentation really comes in handy when you find yourself in a jam and you need to access some resource to get out of it. So let's take a look at some of the items here, like service manuals. You're going to want to hold on to all service manuals for all the different devices in your environment. Now, this is a lot easier in today's world because 99% probably, if not 100% of these service manuals are electronic. Okay, so it's a lot easier to just keep a folder out in your network of all of your service manuals. But if you have any service manuals that are physical manuals, make sure you have a good location for them. All right, it's very important to keep track of that. You want to have good diagrams of your environment, including your network and the architecture of the various servers on that network and the data flow, as far as how data is getting from those servers out to the various clients on your network. Again, this is stuff that seems, in the moment that you're building out your server and your network environment, it seems like, oh, well, this is just obvious. I don't need to diagram this. Who wouldn't know how this works? Well, trust me, as a network grows, it's very important that you have it documented so that when you have a problem, you can really fully understand where to go begin troubleshooting that problem. Some more basic aspects of documentation would be you want to have very clear documentation on recovery processes. This is something that I'm kind of really slowing down and emphasizing here, because anytime I teach in any of my courses about backup and recovery, I talk about how, yeah, sure, there's backup technologies and backup procedures, but it's the recovery procedures that matter. And let me tell you something, when you have data loss, that becomes a panicked environment. So the last thing you want to do is be stressing over okay, can I remember here? What am I supposed to do? How do I get the No. Just simply go to your recovery documentation that will tell you, right? You write it when you are calm. You write step-by-step instructions. And then when you're panicked, you can go, oh, okay, now let me go to that documentation that I created when I was calm. Trust me on this, very, very important. Another piece of documentation that's very important to have is change management documentation. Documentation that actually references what on your servers is going to be updated. When was it updated? Has it been updated? Maybe it's not going to be updated. You've chosen for a reason not to. Okay, these are all the different details that you have to have in your change management procedures, so that you're not just winging it, and so that different administrators don't come in and maybe have different methods. And one final piece of documentation that I'll say that you should have handy is your service level agreements with any of the various vendors. Now, this can be a service level agreement as far as something you're providing, or it could be something that they are providing to you. but this will just help keep you out of a legal situation and make sure that everybody is providing the level of service that they are supposed to. Sorry to beat the dead horse here, but it's really important to make sure that you understand how important documentation is. I'm telling you, it doesn't seem like it's important. So you need to hear me in your head saying, document, document, document. One of the most important configuration aspects of a server is making sure that it has its networking configuration set up properly. Now, we've already seen, because my machine here, I have not taken the time to set up properly. We've already seen where that has caused problems. And in fact, even back when we went to go install a role onto this server, we were given a warning saying, hey, you should make sure that you configure networking before you do this. And in fact, we even saw an error in the process because of it. Now, every operating system has its own way of configuring networking, but in the world that we live in now, here's the thing. You have to know how to get your server out on a TCP/IP network in a way that it can communicate with other servers. Very often, it has to be able to communicate with the internet. And most importantly, it needs to have a way for the clients to be able to communicate with it. Otherwise, the server doesn't really serve much purpose. So let me just demonstrate here on Windows Server 2019 how we would do this. Here in the Server Manager, we know that we click on Configure this local server. We have the ability to configure our Ethernet connection here. So I'm going to click on that. And then here we have our Ethernet connection, which I will right-click and select Properties. And then here in this Properties window, there's two different versions of the Internet Protocol. We have TCP/IP version 4, and we have TCP/IP version 6. Now, TCP/IP version 6, if you're using that on your network, really all you have to do to configure it is just a matter of checking a box. There's not a whole lot that goes into the actual configuration of TCP/IP version 6. And I'm going to actually uncheck that box. And let's focus on IP version 4. With IP version 4, you highlight it and go into the properties. And you'll see here that I right now am set up to obtain my IP address automatically. Okay, that means that I'm getting my IP information from a DHCP server if one exists on my network. You'll also notice in the bottom half of this window, I'm also getting my DNS server from the DHCP server. In other words, I have another server out there that is telling this server, here's an IP address for you to use. Oh, and here's the IP address of a name server, a DNS server for you to use if you want to get out on the internet. Very often on our servers, we want to set this up statically though. Now there's a couple options. One, out on the DHCP server, we could set up what's called a reservation, which means that even though I'm getting my IP address dynamically, I would be given the same address all the time. But in some cases, some services require that you have to have an actual static IP address. So to do that, you click on Use the following IP address. And then I could type in something that would work on my network. Now I'm on the 192.168.1 network, which is a private network here in my office. Okay, so I could go ahead and I'll just, I think 240, just pick something that's on that network that I know isn't being used. And then when I click away from that, you'll see here that it automatically populates a subnet mask of 255.255.255.0, which is the default subnet mask for anything on the 192.168 range of IP addresses. So that actually is correct, but if I needed to change it, I could. I need a default gateway if I want to communicate off of my network. I happen to know that my default gateway is 192.168.1.254. And then I need to also have DNS servers in the event that I want to get out on the internet, which again, on my network happens to be 192.168.1.254. All right, so that's how I could go ahead and I could configure it statically. All right, so I could just click OK. And now I have configured my static IP configuration for this server. Now, one thing that's important to understand when it comes to networking and our servers is understanding the various protocols that are commonly used and accessed. You should understand what a protocol is. It's a set of rules and procedures for communication. Okay, so we have the different rules and procedures for computer communication set with the various protocols, depending on what type of communication we're going to have. So I just want to kind of quickly go through some of the common protocols that you'll find people are accessing your servers with and what ports that they communicate with so that you can make sure that your firewalls are set up appropriately. So the first would be HTTP, which is just our basic web content, which can be found on port 80. I mean, this is probably the number one most commonly used protocol in today's world. Probably a very close runner-up, and maybe actually is number one. Maybe this one is number two, but number one might be HTTPS, which is our secure web content, because everything's all about security now, very often secured through SSL, and that uses port 443. So again, these are important because if you are going to be a server administrator and you are managing a web server, obviously web content is going to be provided, so you want to make sure that you understand that ports 80 and 443 are available to your clients. But let's say that we were managing email servers. Well, then we have some of our email protocols like POP3, which is used to receive email from an email server where messages can be stored out on the client, and it uses port 110. And there's also a secure version of POP3, which uses port 995. Another way of receiving email from an email server is through the IMAP protocol. The one big difference is that the messages stay out on the server. Okay. So again, I don't want to get deep, sidetracked here into all about email, but that is the difference between POP3 and IMAP is whether the messages stay on the server or if they can be stored on the client. IMAP uses port 143, or it also has a secure port of 993. And then we have SMTP, which is used for actually sending the email between the email servers, which uses port 25 or a secure port of 587. Now, just a few others that we have out there that are commonly used might be FTP for the transferring of files, which by default uses actually ports 20 and 21. And then there's the secure version of FTP, all right, for the secure transferring of files, and that uses ports 989 and 990. Now, this is maybe a little bit out of date, but still, I would think a protocol you should be familiar with, which is Telnet, which gives terminal emulation. Okay, I talked about in another video where, older servers, you may actually connect with a serial cable and you may actually use a Telnet session. Okay, if so, that's via port 23. And by the way, you can also do Telnet across the network. That's why we have a port for it. We talked about remote management, right? We have remote desktop management, which is port 3389. And then, I'll tell you what, a couple of protocols that probably our networks wouldn't even work without. We have DNS, which is used for name resolution, and that uses port 53. And then we have DHCP, which provides dynamic IP configuration out to our clients, which uses ports 67 and 68. Yes, I know this is maybe just some memorization. I don't have any little trick for you, but that's just a few of the common protocols and the ports that they would use that you would need to have available on your firewall if people need to use these protocols to connect to your servers. In today's world of networking, we more often than not hear everyone talking about wireless networking. Well, very often our servers, even in today's world, are still physically connected to our networks by using network cabling. What I'd like to do is just kind of do a quick overview with you here on the two types of network cabling that you may need to be familiar with when connecting your servers to your network. The first would simply be Ethernet or twisted pair cable. Now, again, quick overview, not going to go into the great detail on this. We have different courses on actual cabling if you're going to be a cabling specialist. But as a server administrator, it's important that maybe you understand about cabling purchases that may be pushed your way or that you may need to present to somebody. Now, when it comes to Ethernet cable, it comes in many different categories. It actually starts down with category 1. But I'm going to tell you that in today's world, there is nothing less than category 5 that could be practically used. And in fact, many people consider category 5 to already be, the quote unquote slow cable out there because it only provides 100 megabits per second speeds. But we also have category 5A, which gives us gigabit speeds, and category 6, which I want to forewarn you with category 6, it gets a little bit confusing. You're going to want to look at the specific vendor and the specific purchase because some category 6 cables are also rated at only 1 gigabit and some are rated at 10 gigabit. And in some cases, they'll call it category 6A to get you 10 gigabit of speeds. Now, when it comes to patch cables, right, these actual cables that you'll have and you're making connectivity, I want to just give you a quick explanation. The idea here is not teaching you how to create these. It's just maybe to know what you're looking at. So the main type of patch cable and the only type of cable you should see, hopefully in today's world, would just be your typical straight or straight through cable. On the screen near the bottom, I have the TIA EIA standards, which show the wiring configuration with the different colors and where they go for 568A versus 568B. And the idea is with a straight cable, you'll have 568A on both ends, okay? And so, you may, if you are grabbing a cable to go use, you may need to hold it up and look at the two connectors and make sure that you have the same colors in the same order to know that it's a straight through cable, because that's the type of cable you'd want to use. Now, the reason I mention this is because in the old days, we used to have what was called a crossover cable, which was a cable that was specifically designed to connect one computer directly to another computer. Okay, so not through a hub or a switch or a router or anything like that, but literally just two computers connected directly to one another. In a crossover cable, you have 568A on one side and 568B on the other side. And so if you ever come across a cable and you're trying to figure out why it doesn't seem to be working right, if you hold up the two jacks next to each other, if you can see that the colors don't actually line up properly, that some of them are switched around, that's the problem you might be having. You might have an old crossover cable that was laying around. Now, the other type of cable that we have out there is what's called fiber. Now, this is not something that you necessarily would be connecting directly to the server typically, but as a server administrator, you still may be involved in an acquisition of these cables. All right, so I want you to know that fiber basically comes in two different flavors. First is what's known as single mode, and this is a cable that has a single beam. It's very narrow, that can go very long distances very, very fast. And then there's multi-mode, which is where you have multiple beams. And as a result, it's going to be wider and can only go shorter distances and is a little bit slower. Now, keep in mind that this is all still relative, okay, because multi-mode fiber is still typically faster than most Ethernet cable. All right, so those are the two different types of cables that you want to be familiar with. You have your Ethernet cable and your fiber or fiber optic cable. While many servers, even in today's world, are still physically connected to our networks using actual network cabling, you may find yourself in a situation where it makes more sense to use wireless networking to connect your servers to your infrastructure. Now, there are a number of benefits that come with using wireless networking, just in general for your networks, but I'd like to talk to you here about the benefits as it is specific to your servers. First of all, it's easier installation. If you find yourself in a situation where you are setting up servers in a location that has not been previously cabled, then it's much easier to set up a wireless network than it is to run cables to that location. Along those same lines, we have an extended reach. So you might be able to get network connectivity to a location that you otherwise would struggle to do so with physical cables. I'll give you an example. Let's say that you are operating in an older brick or concrete based building where you don't have an easy ability to run cabling through the walls. Well, if that's the case, then we now have the ability to get a wireless signal to travel to those locations without having to figure out a way to either put some additional channeling or breaking through the walls. There's also increased
flexibility. So if your network changes in the future, well, you can easily change the wireless network to go along with it. And again, without having to run new cabling. So example here would be maybe you decide to move your server room, especially as your company grows. If you were to maybe have just a small set of servers that were in a closet, and you now realize that you need to implement a formal server room as you grow, need more servers, well, you may not have cabling in the new location where the server room is, so you can quickly and easily move the wireless network without much hassle. And it's also very scalable. So again, as your network grows, well, a wireless network can be expanded very easily, whereas a cabled network would very often require more cable runs. So if you're not getting the idea here, the main benefit of using wireless is to avoid some of the hassles that go along with physical cabling. Now, if you already have physical cabling in locations where your servers are going to be, well, then many of these benefits go away, and you just have to decide what's going to work better for your specific environment. So let's talk a little bit about storing data on our networks or on our servers. All right. Now, when it comes to the actual storage technologies on our servers, we're really talking about our hard drives, right? And we have two main types of hard drives available. Now, we have the traditional kind, which are magnetic, okay, which is the kind of drive which actually has magnetic disks and a read write head and a whole lot of moving parts. Now, there's still plenty of these types of hard drives out there because, from a cost factor, these types of drives can be gotten very inexpensively. But the more popular kind that we're seeing every day, especially as the prices are coming down, is SSD, which is a solid state drive, which is one that has no moving parts. It's all done through circuitry. These drives are quieter, faster, and more durable if they were to get jostled around. All right, so you want to keep in mind those two different technologies. Now, if we go back to the magnetic drive, it's important for you to understand the different specifications of these drives. First is the RPMs, or revolutions per minute. All right, now I actually have a picture on the screen of what a hard drive would look like if you opened it up. And you'll see here that you have these actual disks. Okay, you have an actuator arm, and then there's heads on the end of the arm. Well, those disks are spinning around. So the RPMs are how fast those disks can spin. Now, you have the actual dimensions. Okay, so the physical size of the drive itself, because it's got to be able to fit into the drive bays that you have in your servers. Of course, we have capacity. How much data can we store on the hard drive? And then even though we have RPMs, which is a kind of a factor of speed as far as how fast the heads can read and write data, we also have the input-output speed as far as how fast a hard drive can transmit that data back and forth from the system. Then we have seek time and latency, okay, which basically has to do with how fast the actuator arm can move to the location where it needs to be finding something on the disk. And then one of the most important, what I think is most important specification that you should be looking at when buying one of these drives is it hot swappable? Okay. We've talked about hot swappable technology a couple times so far in the course. And basically, when it comes to servers, you want to be able to swap things out without having to shut down the system. Well, when it comes to hard drives, we also want to have a configuration set up. Okay, we might have something like RAID, which we'll talk about in a little bit later, but which allows us to actually take out a hard drive while the system is still running and it'll still function, and then swap in a new one. But you can only do it if you have hot swappable technology. Now, some of the overall storage technologies is, first of all, we have direct attached storage. This is really what we've been talking about so far as having an actual hard drive, right? Where it's in the actual server itself. But there's also network attached storage, okay, which is where you basically can have a storage device that is accessible to the server over your TCP/IP network. We have our storage area network. You gotta love that they did NAS and then reversed the letters to SAN, both for storage technologies. But the storage area network is basically a high capacity storage device that is connected by a high speed private network, which is separate from the LAN using a specific storage switch. It's a storage information architecture that addresses the collection, management, and use of the data. Okay, so it's a very sophisticated network-based storage as opposed to a very simple network-attached storage. And then we also have something called just a bunch of disks, which I thought about mentioning just a bunch of disks, when we talk about RAID in a different video, but I'll talk about it here. And it's the idea of we now have technologies to where in our servers, we can actually just put a random sampling of different sizes, makes, and models of hard drives, and we can have them work together with one another to form one large volume, or you can even create different volumes within those physical hard drives. These are all options that we have available when it comes to storage in our servers. Now, when talking about storage on servers, we really can't do it without talking about RAID. Okay, so what is RAID? Well, first of all, the letters RAID stand for a redundant array of independent disks. It's the idea of having multiple disks, putting them together in an array so that they can function together as one logical storage entity. And the idea, typically with RAID, is to provide what's called fault tolerance, okay, which means that if you have a drive fail, your system can continue to run. So let's look at some of the different options when it comes to RAID. First, we have RAID 0, or what's known as disk striping. Now, before I go any further, I do need to mention, since I just a moment ago said RAID is all about fault tolerance, you need to know RAID 0 does not provide fault tolerance. If you were to lose a drive in a RAID 0 array, you would lose the data. So you may think to yourself, well, why do we do it? Well, first of all, you have to have at least 2 disks. You can have more, but you have to have at least 2. And the idea is that you will stripe the data, as I have illustrated here. If you see here, let's say there's the 8 blocks of data. They're labeled A1 through 8. You'll see here that we're putting a block on one disk, and then we put a block on the other disk, and we go back and put a block on the first disk, and then the other disk. Well, the benefit to this is that you have an increased read performance when trying to read data from those disks. You can actually be reading from both drives simultaneously. So if half the data is on one drive and half the data is on the other, well, then you get a somewhat almost twice as fast read time. It's not quite twice as fast because there's some processing time, but you do get some increased read performance. Now, with RAID 0, you do have 100% drive space utilization, meaning however much drive space you've purchased, you can use all of it and you can have that much data. Now let's look at RAID 1, which does provide fault tolerance. RAID 1 is what's known as disk mirroring. With RAID 1 or disk mirroring, you have to have exactly 2 disks. So it's not at least 2, it's exactly 2 disks. With these 2 disks, what you're going to do is, I have it illustrated here, is every data block that is written to one is also written to the other. So this might seem very obvious, right? Everything's being written to 2 drives at the same time. You basically have a drive and then a backup drive. Now, I will tell you, you do get increased read performance. And the reason why is because, well, what you could do is, if we needed to pull, let's say, data that was in blocks A1 through 4, we could be pulling some of that data from one disk while simultaneously pulling some of the other data off of the other disk. So you do get some increased read performance. Now, I do need to mention that you only get 50% drive space utilization. Okay, what that means is, let's say these are each a terabyte drive. So I've purchased 2 terabytes of drive space. Well, I can only store 1 terabyte of data because everything that's stored on one is also stored on the other. And it does provide fault tolerance in the case one of the drives fails, right? If one drive fails, the other one still has all the data. And then we have what is probably one of the most popular forms of RAID, which is what's known as RAID 5. And it's also called disk striping with parity. Now, this form of RAID requires a minimum of 3 disks. So this is 3 or more disks. And the idea is what we're going to do is you're going to stripe the data across all the different disks. The illustration I have on the screen, I have 4 disks. You'll notice that you have block A, 1, 2, and 3, but then there's what's called a parity block that's put on the 4th disk. And then you'll see here with the next stripe, B1, 2, and 3, we've moved the parity bit over to a different drive. And then same thing with C and same thing with D, and we just keep rotating that around. Now, again, we do have increased read performance because we can be reading from multiple disks at the same time. We also end up with more efficient disk space utilization. I can't give you an exact number because it depends on how many drives you have. All right, so the example here where you have 4 disks, well, 3 of the disks contain data and 1 has a parity bit. Okay, so that means that you end up with 75% disk space utilization. If you had 10 disks all working together, well, then you would end up with 90% disk space utilization because only one of the 10 has the parity blocks, okay? So it is very efficient with disk space utilization, and it also does provide fault tolerance in the case of a single drive failure. What happens is if one of these disks was to fail, the data that's on that disk could be rebuilt based upon the parity block on the other disks. All right, so that's why RAID 5 is actually a very, very popular form of RAID, is because it gives you good speed, it gives you good space utilization, and it gives you fault tolerance. Now, I also want you to know that there is the option of putting these forms of RAID together. And I gave you just a couple of examples here, which is you have RAID 01 or RAID 10, okay, which RAID 01, to give you an idea, is where you have 2 stripes that are mirrored versus 10, which is where you have 2 mirrors that are striped. Well, really, I should say 2 or more mirrors that are striped. You can do this with any of the different forms of RAID. You could have RAID 15 or you could have RAID 51, things like that. But RAID is something that you definitely want to be familiar with. I will tell you there are other RAID technologies out there. There is a 2, 3, and 4. There is a 6. There's a number of them out there. But these are the most popular forms of RAID that you should be familiar with. When it comes to figuring out storage for our servers, the obvious is to think about the different storage technologies we'll use or what kind of fault tolerance we're going to provide. But one of the most important things to consider is capacity planning. Because one of the biggest problems we run into is if you don't have capacity planning, well, you suddenly run out of space when you weren't expecting to. So let's talk a little bit about what we need to consider when it comes to capacity planning. Well, the first thing to keep in mind is that, believe it or not, the operating system itself, okay, you don't even have to have any specific users doing anything. The operating system itself will grow. Why does it grow? Well, it grows because we are constantly patching it. Okay, we're applying maybe additional service packs to it. We have log files that are being generated and temp files which are being generated. So these are all things that are going to make the operating system take more space on your hard drive.
And then, of course, we have our actual data growth, right? You have your actual customer data. As more and more customers come in, more and more data goes with them. You have to have a place for archive data, some of your older data. You have to figure out what you're going to do with it, and recovery data. How do we store enough so that we can go ahead and get ourselves back in the event that we have data loss? So what are some of our mitigation strategies? First of all, we could implement something called disk quotas, which is where we literally restrict how much data our individual users can store out on our servers. Okay, now you want to be careful with this. I will tell you, I'm not going to go into detail on all the ins and outs of setting up disk quotas, but you want to probably set what's called a soft quota, which means you get alerted and maybe the user gets alerted that they're storing too much data, as opposed to actually restricting them and making them emulate that they've run out of space. Another thing you can do, although I really strongly recommend that you be careful with this on your servers, is use what's called compression. Okay, so you can compress the data to save space. The problem is with compression, you have a pretty significant loss of performance when accessing that data. So the only place that I ever recommend that you compress data is either backed up data or archived data. Now you can also have regular cleanup routines that run, because we talked about, like, for instance, why the operating system grows. You have a lot of temp files, right? Temporary files. Well, a regular cleanup would take care of that, as well as if you have some kind of a cleanup process for any data that your users have saved that is not important anymore. And then you also can have a routine archival where you take a look at data that maybe hasn't been accessed for a certain amount of time and then archive that out to an alternate location. This is just something, it may seem pretty basic and to the point, but is actually really important to make sure that you have capacity planning on the mind when you are considering storage for your server. When it comes to keeping the data on our servers secure, the first and most basic line of defense is the idea of assigning rights and permissions to various user accounts. Right? It doesn't matter what operating system you're using. They all have some aspect of this. And the one thing I will mention is that this just makes for confusion, but some vendors choose to call that a right and some choose to call that a permission. Now, in the world of Microsoft, giving the user the ability to access a document, for instance, that's permission. Again, other vendors might call that a user right to access or an access right. So let's just kind of look at this real quick. Here on my Windows Server 2019 computer, I'm going to go down to the taskbar and click on this little folder, which opens up my File Explorer. And if I navigate here on my C drive, I have a folder I created called Demo Data, and there's a document called Demo Document. I did this for the sole purpose of being able to just show you that if you right-click on this document and go to its properties, and then click on the Security tab, this is where you have what's called an access control list. This is something that would be similar on any operating system, to where we see a list of users and possibly even groups, which are very common to be able to go ahead and give permissions to multiple users at the same time. And not only do you have the list of users and groups, but then down at the bottom, you have the actual permissions on what can be done to this particular document. In fact, let me cancel out of there. I could also go to the properties of the folder and again, go to the Security tab. And again, we have an access control list. And then we also have the permissions. And the permissions have to do with pretty much now everything inside that folder. Okay, so maybe you can give permissions now to a lot of documents as opposed to having to give permission to each individual document. All right, so that's just kind of like the general idea of giving access control to your users to help keep your server secure. Now, since I mentioned the aspect of rights and permissions, let me just kind of quickly show you here in the world of Microsoft, giving the right to a user has nothing to do with actually accessing data. It has to do with being able to perform a function. That's what a right is in the world of Microsoft. So let's take a quick look at configuring some of those rights. Now, typically, you would be in a domain environment, and this would be managed at the domain level. But because I just have this one individual machine, we're going to look at it on the one machine. And the way I do that is by clicking on Start, and then I'll start typing the word group. And you'll see here I have the ability to edit group policy. And again, this normally would be done through Active Directory and the Group Policy Manager. But in this case, it's just going to be the local group policy editor. Under the computer configuration, I'm going to expand Windows settings and then expand security settings and then expand local policies. And you'll see here that I have user right assignments. And here we have a whole list of certain activities and then the users who can actually do that. So I'll give you an example. Allow log on locally. Who can log on locally, meaning physically at this machine? We'll talk about that as far as physical access to a server is kind of a big deal. Now, in this case, because it's just an individual machine, it's not part of a domain, you'll see here that this one actually allows pretty much anybody. I mean, you'll see the users group can actually log in locally. That's not a good idea typically on a server. Servers usually only want to let administrators log on locally. Another example might be being able to shut down the system. You'll notice a regular user cannot shut down the system. Okay, so the only way that a regular user would be able to do it would be to physically, basically turn off the computer. All right, so that's just kind of like the basics when it comes to that first line and the most basic line of defense to keeping your data secure, which is being able to assign user rights and permissions. Another way we can help keep our data safe and secure is through the use of encryption on that data. Now, each vendor has their own versions of how we can encrypt data, and there's even third-party encryption. Now, in the world of Microsoft Windows Server 2019, there's a couple options available when it comes to encrypting our data. The first is actually just done through our basic file system. So again, I'm going to go to my File Explorer here, and I'm going to jump back onto my demo document here that I had created. And I want to show you when I go into the properties of this demo document, right here on the General tab, if I click on Advanced, you will see here that there is a checkbox available for encrypt contents to secure data. If I were to check that box, this is something to where basically users can do this on their own to where they are making it that only that individual user now has access to that data because it's been encrypted. There are other courses where I go over this in very, very great detail, but basically it's the idea of using both symmetric key encryption along with public key encryption, where you create a security by encrypting this document using the user's individual public key so that it can only be opened with their private key. Now, I don't want to go into great detail here, and I'm going to cancel out of this and not do that. I just wanted to show you that you can do that. In the world of Microsoft, that's called the Encrypting File System, or EFS. But there is something else that we can also do if we want to encrypt the contents, truly keep a hard drive secure, especially if we're worried about somebody maybe stealing the hard drive. If we're worried about the aspect, especially if, and then this is a little bit unusual, this might be more so on a laptop than it would be on a server. But I suppose if you're using a laptop as a server, maybe this is something worth doing. But even on a server, if you're worried about somebody getting physical access and stealing the hard drive, you may want to do this. So here in the Server Manager, I'm going to click on Add Roles and Features. Here's my basic Before You Begin screen. We saw that before. I'm going to click on Next. I'm going to do a role or feature-based installation. Click on Next. It is going to be on this particular server. Click Next. Now, it's not a server role, so I'm just going to click Next right past this screen. But it is a feature. You'll notice here that I have BitLocker Drive Encryption. And if I highlight that, you'll see here it says BitLocker Drive Encryption helps protect data on lost, stolen, or inappropriately decommissioned computers by encrypting the entire volume and checking the integrity of the early boot components. Now, I'm not going to go into more detail on this, but if I were to just simply check the box, it would then say I need some other things, and I'd say fine, and I click next, and now it would go ahead and set up this server for BitLocker encryption. I will again hit cancel because I'm not actually trying to do this on this particular demo machine. I'm just trying to give you the idea of understanding that we do have encryption capabilities to help protect and keep our data secure in the event that maybe there was going to be some kind of unauthorized access to it. So now let's talk a little bit about something called server hardening. And really what it means is, if you kind of turn the words around, it means making it harder to break into your servers or into your systems. All right, so the first area that I want to talk about when it comes to hardening your servers has to do with the software side of things, specifically the operating system and the applications that are installed. So the first thing you want to do is you want to make sure to stop, or even better would be uninstall, any unneeded or unused services. For every extra service that's running on your system, that's one extra vulnerability that somebody might be able to break in through. Along those same lines, close any unneeded communication ports. If you know that you have a server that has a very specific purpose and only needs to have certain types of communication, well, then make sure that you close off any ports that are unrelated to the specific services that that server is providing. Now, most server operating systems from any vendor have some form of software firewall to where you can open and close the ports on that specific server. Okay, as opposed to you may be thinking about out on your actual firewall. Well, that's important as well, and we'll talk about that. But I'm talking about on the server itself, you want to also close any unneeded ports. Now, basically, when I talk about stopping unneeded services and closing ports, I'm talking about anything related to the operating system or applications. But speaking of applications, another thing that you want to do is, well, have as few applications as possible installed on your servers. All right. Many companies, they want to take kind of a lazy approach, which is let's just look at all the software that's needed for the entire company and then let's just install it everywhere. Well, that's not a real good idea because every extra application that's installed means you're going to have extra services and ports open and therefore extra vulnerabilities. So only install the applications that are necessary on your servers. And then finally, and this is actually a really important one, is make sure that you are keeping your security patches up to date. The problem is that every time a vendor puts out a new security patch, what they're doing is they're actually announcing to everybody, hey, we have found a potential vulnerability. Well, guess what? The bad people out there, they watch for that, and then they will try to exploit that vulnerability based upon anybody who has not actually implemented the latest and greatest security patch. All right, so you want to make sure that that is absolutely taken care of on all your servers. So now let's take a look at this from a hardware perspective. First of all, you want to disable any unneeded hardware and physical ports or devices. You don't want to let somebody have the ability to physically connect in through any port that's maybe just sitting vacant or unused. You can also do some basic things like implementing a BIOS password, which makes it so that if somebody were to gain physical access to the server and let's say reboot it, they wouldn't be able to get into BIOS and make changes from that perspective. You want to disable something called Wake on LAN, which is the ability for somebody to wake up the server via the network. Okay, maybe you have your server shut down as a matter of protection, and you don't want somebody to be able to literally boot up the computer by connecting via the network. Now, this one seems a little bit, like, why are we doing this? Why is this security based? Okay, set appropriate boot order. Why does that matter? Well, the reason it matters is because very often a system will come with a default setting of booting off something other than the hard drive. And again, if somebody can get physical access to the server, and then they know that there's something else that can be booted off of before the hard drive with the operating system, well, then they're going to go ahead and they're going to plug in one of those devices and boot off of their own device to get into your server. Finally, we just have the idea of physically locking up the server. All right, so that is kind of a way that we can go ahead and harden our servers. We can do it by locking down our software to having only what's necessary, and then also locking down the hardware to protect against somebody physically gaining access to the server. So now let's talk a little bit more about actually having physical security, right? In server hardening, we talked about doing things to protect your servers in case somebody physically gains access. Well, now let's talk about preventing physical access. So what can we do? Well, the first thing, just first nice simple line of defense, is having surveillance cameras. Okay, now these cameras can range from as simple as just recording what's happening, and that way if there is a breach, you can go back and look and see who it is. Or you could have some kind of motion sensor system to where it alerts an administrator or a security personnel if it senses somebody is present. Now, speaking of security personnel, how about something as simple as a security guard, right? Having actual humans guarding and protecting your servers if you have stuff that is, important enough that you really need to keep somebody physically out of the room. One of the best things you can do is actually have a human who's there to protect it. And here's a fun one that I always like talking about, and it's called the man trap. Let's expand upon this man trap a little bit here. So you can see here that the man trap is a room that has 2 doors in it. And the idea is that these doors have separate security. Now, you can get real elaborate with this separate security in the sense that you could have completely different security mechanisms, or even if you had the same, so let's just keep it simple. Let's say you got to enter a passcode. Well, have a different passcode on the second door than you do on the first door. And the idea behind this is somebody can enter their code and get through the first door, but you can't go to the second door until the first door is closed, period. In other words, even if you had the code to the second door, you can't get to it until the first door closes. The idea here is that you're doubling up on physical security, and very often somebody might not even realize that there's a second door or realize that they need a different code, right? They finally steal the code to get in the first door, and they enter the code, they go in, and then they enter the code for the second door, and it doesn't work. And now they're trapped, okay? Because the first door, you want to have it lock behind them, by the way, and that way they're locked in. You have to have security to get in and out of the room in either direction. Now, the next thing I want to talk to you about is something called multi-factor authentication. Now, we usually talk about multi-factor authentication when we're referring to actual rights and permissions, actual access control to stuff on a server. Well, I'm talking about multi-factor authentication with regard to physical security. Because yes, we do have it, and it is basically the same concept. The concept is you have 3 forms of security, right? There's what you know, what you have, and who you are. If we use any one of those, that's single factor authentication, right? So the example with the man trap, I talked about having a passcode. That would just simply be what you know. That's all you need to get in. But if we were to add a second form of authentication, like maybe you have to have an actual key card, that would be what you have. And you have to know the passcode. That would be multi-factor authentication. And the third factor, of course, is who you are, which is biometrics. So let's talk about the what you have and who you are in a little bit more detail. So as far as what you have, well, it could be as simple as a picture ID, especially in that scenario where maybe you've hired a security guard. You may, in order to get into the secure area, have to actually show a picture ID of proving who you are. Or maybe you have some form of key fob, right, that you have to go tap up against a sensor, which, by the way, the technology it uses is something called RFID, okay, where you go ahead and RFID with this key fob to get into a room. Could have an actual smart card. Now, smart cards are usually referred to when it comes to authentication to an actual server. So I wanted to throw it in there because it's kind of like physical security to the server, but it's really more to the server than the server room. And these days, we now even have the ability to have this secure access, sometimes by just simply having a smartphone, and maybe there is some security software that's been installed on that phone so that you can physically have the phone with you to be able to get in. And then, of course, there's biometrics. Could have a fingerprint scanner, right? Someone has to scan their fingerprint to get in the room. Could be a retinal scanner. They look at your eye. Could be facial recognition where they look at your face. And this is my favorite one. I did this course about 5 years ago, and I talked about, DNA scanners, the future. We're right on the edge of possibly even having to check your DNA to get in. Well, while that may exist, it certainly is not commonplace yet. And we are still, and now we're 5 years down the line from the last time I did this. But I wanted to leave it on there that we are still right on the cusp of having this be somewhat commonplace for DNA scanners. So again, the idea is with multi-factor authentication, you have to do 2 or more of these things. You have to know something, you have to have something, and or you have to be someone to specifically be able to physically gain access to your servers. All right, and so that's just a little bit about how we can keep our servers physically secure. So let's talk about how we can keep our servers protected from potential power issues. The main device that we can use to protect our servers is a really good quality UPS, which stands for uninterruptible power supply, or to put it in straight lay terms, would be a backup battery. So the idea is, on its most generic level, is you have this box of batteries and it's plugged into the wall so that it can get power from the wall, and you have your servers then plugged into the box so that if you lose power from the wall, the batteries inside the box will provide power to the servers. Okay, well, it's a little bit more sophisticated than that. You want to actually pay attention to a few things when you go get your UPS. First thing is you have to decide how long you want your servers to be running on backup battery in the event of a power failure. Now, here's the thing. Battery backup is not for business as usual. The idea of battery backup is to just simply give you enough time to have a graceful shutdown of your servers rather than a hard crash when the power goes out. If you need to have business as usual, even in the event of a power failure, then you need a generator. All right, so you need to decide how long it would take to get everything to shut down properly. You also have to decide on capacity. Which devices are crucial to have running so that we can do a graceful shutdown? And how much power do they require? And then when you are looking to get a UPS, you want to look at the rating of how much power it can provide and make sure it's enough for your devices. Now, one nice feature that pretty much almost all of today's UPSs can provide, I remember when this was like a really new, exciting feature, but now it's pretty much commonplace, which is the idea of being able to have an automated graceful shutdown. Okay, so the idea is that once you've lost power from the wall, the UPS can notify the server, hey, we're now running on batteries only. And then the server can go ahead and say, oh, well, then I better start going through a shutdown process because I only have a limited amount of power. Now, you do want to be a little bit careful here because you want to have some kind of threshold that needs to be crossed before you actually start the shutdown process, especially if you live in an area where it's not uncommon to lose power for 10 seconds here, 30 seconds there, maybe a minute. So you may want to actually have a threshold of once you've been on battery power for 5 minutes or 10 minutes, then you say, all right, this is a legitimate power outage. We need to have a shutdown process begin. Now, another feature that is commonplace in most of today's UPS units is the ability for remote management so that you can sit in the comfort of your own desk and manage the UPS from there rather than having to go into the cold, nasty server room and manage it that way. Now, some other features that we don't really think of it as a UPS. Very often you can get these things in just any sort of power distribution unit or power strip is things like power conditioning. Some older or very, very inexpensive UPSs, the way they work is basically, even though you're plugged into the back of the box, the servers are getting their power from the wall. So from the power company. And only when we lose power to the wall does it then switch over to the batteries. Well, what you really want is to get one where the batteries are being charged by the wall and the servers are always being given power from the batteries. And this way you can have what's called power conditioning, which means it'll keep a consistent flow of power regardless of any peaks or valleys in the power that's coming in from the wall. Okay, so this will help keep your servers very healthy. Speaking of peaks, let's talk about an extreme peak. Surges. If a big surge of power comes in, you don't want it to blow your servers, so you want to make sure you have surge protection in the UPS that you get. And one last thing I want to tell you about UPSs is just remember these are batteries. Batteries don't last forever. So you don't want to find out the hard way that your batteries are dead when the power goes out. So you should periodically test your UPS to make sure that the batteries are still good. And usually you'll know. It's not like they're perfect and then they're dead. There'll be a weakening process. So you'll see it starting to fail before you're at an absolute failure. But you do want to make sure to periodically test. And by the way, there are test buttons and things like this. But what I recommend for a true test is literally pull the plug from the wall and see what happens. But again, you want to be a little careful with that because if your batteries are dead and you pull the plug from the wall, you might get a hard crash on your servers. So make sure you have everything backed up if you're going to do that. So this is a little bit about how we can protect our servers from a power perspective. Next, we want to talk about keeping our servers safe from an environmental perspective. So the first thing is, let's talk about some of our HVAC issues. Right? You want to make sure that you have an appropriate temperature in your server room. If your server room gets to be too hot, then your servers may be at risk of overheating and having problems that way. Well, believe it or not, if it were to get too cold in the server room, and this is one that people are like, well, wait a minute, I've been in server rooms and they're pretty cold. No. I'm talking about if you get down near freezing and things like that, then you can end up having condensation actually start to build up on your electronics, and that's not a good thing either. So you want to make sure that you are very focused on having good temperature control in your server rooms. Along the same lines, you want to have good humidity control. If you were to allow your server room to get too dry, well, then you run the risk of basically static buildup. Right? And then you can have electrostatic discharge that can cause problems. And again, if it were to get too humid, almost like I was saying, when it gets too cold, too humid, you end up with moisture building up on electronics, and that's not a good thing either. You want to make sure that you have good airflow. So not just a good temperature and humidity, but you want the air flowing through the room. All right. Now, we talked about airflow inside of a server. Okay, and that's important to keep the individual components of the server cool. Well, one of the ways that we can help the airflow inside the server is by having good airflow in the server room. And speaking of good airflow in the server room, if you have enough servers in your server room, then you may want to go with a concept that is on its most basic level. I like to call it just simply hot aisle, cold aisle. And the idea behind it is if you can just picture a server room that has racks and racks and racks of servers, well, what you want to do is you want to have all the servers facing the same direction in one aisle, and then in the next aisle, have them turned around so that between the servers, you have what's known as a cold aisle, right? Because you're going down an aisle where basically you're looking at the fronts of all the servers, whereas on the opposite aisle behind it, you would have hot aisles. That's where the backs of all the servers are, where all the exhaust of all the heat is coming from those servers. And the reason I'm saying that this is good for HVAC is because then that gives you the ability to actually set up an airflow system to where you actually are exhausting from the hot aisle so that you're sucking that hot exhaust from your servers right up and out of the room. Okay, so that's the idea there behind if you have a large enough server room with the hot aisle and cold aisle. Now, some additional safety issues, and this is safety for both, I will say, humans and for the servers, is you want to make sure that you have appropriate ESD or electrostatic discharge procedures. So if anyone is ever going to be touching the servers, especially if they're touching the inside of the servers, Make sure that you have appropriate ESD protection and procedures in place so that mostly the equipment in this case does not get an ESD charge and fry it that way. Along those same lines, you could say it protects the humans so that if it's a surge of power in the other direction, you want to make sure the humans are protected. You want to have good fire suppression. Okay, so if there's a fire in the server room, make sure that there is a way for that fire to be suppressed quickly and safely. Rack stability, making sure that your server racks aren't ready to topple over, because that could be extremely dangerous if that were to happen. And along those same lines, you got to keep in mind there's a lot of weight when you have a lot of servers in these racks. And very often in these server rooms, you will have a false floor because you may have cables running under the floor, and or you may not be on the bottom floor of a building. And so depending on how the building is made, you're going to want to actually look at the load limitations, make sure you don't exceed them. And you also want to watch out for sharp edges and pinch points from all this equipment that you have. Again, protecting humans from getting cut, but also protecting your server equipment, mostly like cables and things like that, from being cut and then causing damage to the servers. So that's just a little bit of some of the things you want to think about with the environment of the server room itself. Now, this next thing I want to talk to you about, as much as it does relate to environmental and safety and things like that, it also has to do a little bit with data security. And that has to do with secure storage disposal, right? So what do we do when we are actually disposing of equipment that we no longer need? Let's talk about data itself. Right? If we want to go ahead and get the data off of our drives, off of our systems before we dispose of it, there are some options. The first is just what's known as a simple soft wipe or just a basic deletion. Right? It's the idea of you just take files that you don't need and you say delete. And no, I'm not talking about just going to the recycle bin. You even empty it from the recycle bin. Heck, you might even format the hard drive. But you have to understand that just a regular soft wipe, even though the data, it's said to not be there anymore, it is actually still there. A remnant of the data still physically exists in the circuits, on the magnetic platters. Okay, so you want to be a little bit careful about that. So you may want to go to what's called a hard wipe. Now, a hard wipe is where you basically say, all right, let's go ahead and delete everything. It's not just kind of being marked as not being there anymore, but then you actually rewrite over it again with some arbitrary data. And then that way, the original data is truly physically gone. Now, since we're talking about wiping data, I am going to throw one more thing in here. It's not completely related. Certainly, I don't think with servers per se, but it's the idea of a remote wipe. Remote wiping has to do more with portable devices that you may have in your organization. And if those portable devices were to ever disappear, get lost, be stolen, whatever, then you could implement what's called a remote wipe system. You may be familiar with this. Many cell phone carriers, and really it's not even just the carrier, even the phone itself, will have technology built into it to say, oh, okay, so if it disappears, you suddenly lose it. You don't want to have people getting into all your private information. You do a remote wipe. Well, you can do the same thing with your portable computing devices in your business. All right. Now, the next thing is, once we talk about the idea of actually deleting data, the only real true way to make sure that it has been destroyed and this data cannot be accessed would be through literal physical destruction. And yes, that means where you may actually take a hammer to the device and break the device into pieces. And you want to make sure that when you dispose of those pieces, you take the time to dispose of them separately. And the reason why is because, believe it or not, you might be thinking to yourself, okay, I've smashed this hard drive and it's in 1,000 different pieces. If somebody has those 1,000 pieces, they can, if they're really skilled, they can find ways to get it all reconstructed, almost like a jigsaw puzzle, and figure out how to get back in and get to your data. The other thing you want to keep in mind is when you are disposing of any form of computer equipment, you don't just throw it in the garbage. Okay, it is not environmentally safe to do so. So it's very important that you actually take the time And this will vary from area to area. So in your area, look into how to properly dispose of your computer equipment. Now, I will tell you, by the way, very often, one of the easiest ways to dispose of equipment, once you've made sure all the data has been wiped off and you're not worried about somebody, stealing or whatever, is to actually donate the equipment, right? Because you may be done with it, but it may not actually be dead or broken. And there are many organizations who don't have a lot of money who would greatly appreciate your hand-me-downs. That's a great way to go ahead and help the environment by basically recycling your devices straight into another organization who can use them. And so that is how we can go ahead and we can securely and safely dispose of our storage devices and really any of our computing devices. So let's talk a little bit about some of the benefits of using virtualization with our servers. The number one benefit and most obvious benefit that is realized by most server administrators right away is a reduction in overall operating costs. Now, there are two main reasons for this cost reduction. The first is the obvious one, which is since we have the ability to have multiple virtual servers on one physical server, it means we have to purchase less hardware. So we save money immediately. But the other cost savings that's not quite as obvious is the expenditure on resources to keep your servers cool and dry. Okay, so it's kind of the environmental resources that we have to spend. Well, we're going to spend less money because we have less physical servers. Now, there are three other benefits I want to talk to you about, and they're all related to the same feature of virtualization. We have minimal downtime. And the reason why we have minimal downtime is because we have the ability with virtual servers to quickly and easily clone and create a replica when we first implement that server. So in the event that we have a server that crashes, you can very quickly and easily implement a replica so that you can get yourself back up and running again. Another benefit in that same realm is that you should see increased productivity within your IT department. And the reason why is because the members of your IT team will no longer have to spend time replacing a lot of hardware because we have less hardware, or let's say scrubbing malware or viruses from your servers, because if you were to have a virus infected server, well, now it's just a file basically, right? It's just a virtual machine. So what do? You just delete that file and implement one of your replicas, right? So that's why I said we're going to come back to the cloning of replicas. Or even if you were stuck in a situation where you had to troubleshoot a very challenging problem, right? If a server was just simply acting up on you and you cannot figure out why, if it's not quick and easy, then you say, you know what? I'm not going to spend time troubleshooting it. I'm just going to go ahead and, again, delete the file and implement a replica. So you have much better productivity within the IT team. And then we have overall simplified data center management. So there's a number of benefits here, right? We have redundancy and disaster recovery planning that we have to deal with. Well, it's easily implemented using cloning and replicas. And it's also more scalable because not only can you use a replica to replace a server that has gone bad or has a problem, but you also can use replicas to expand and quickly add additional servers without having to put in much effort. So overall, virtualization technology has the potential to help a number of problems in businesses, both small and large. And these are just some of the benefits that it provides. There are a number of virtualization technologies out there that can help you to quickly and easily implement virtual servers. Couple of examples that come to mind quickly would be Microsoft's Hyper-V, or VMware would be another huge vendor in the world of virtualization. We have entire courses on how to use some of these virtualization technologies. What I want to do here is show you an example of how you can quickly and easily implement a new virtual server using Microsoft's Hyper-V. So what we're looking at right here is the Hyper-V manager that we have on a Microsoft server. And you'll see here that I, over in the kind of the middle top here, you'll see there's a number of virtual machines. And in fact, we saw this screen briefly in one other video in the course, which is when I actually installed the Windows Server 2019 operating system. And I did so on this virtual machine down at the bottom of the list called Windows Server. Now, I had already created that virtual machine before that video. Well, I'm going to show you here how that was done. So on the left here, you'll see here I have a machine here called Recording PC. That's actually the name of my physical computer that I'm running in my office. So if I right click on that computer, I have the ability to go ahead and select New Virtual Machine. And now I get the New Virtual Machine wizard. You get your typical before you begin, where it just kind of gives you an overview of what you're going to do. I'm going to click Next. Now we need to give it a name and location. So I'm going to name this virtual machine Demo Virtual Server, just to give it a name. Now there is a default that is set up, and if I wanted, as far as the location of where this file will be located, right? Because all virtual machines are actually a file. And you can see that there's a default as to where it's going to be stored. If I want it somewhere else, I could check the box saying store it somewhere else. In this case, I'm just going to go ahead and leave it at the default and click Next. Now, I'm not going to get into any real great detail here, but basically in the world of Hyper-V, there are two different generations of virtual machines, and they talk about the differences. I typically go with the latest and greatest unless there's a reason not to. So generation 2, click Next. Now I can assign memory. Now, I have to assign an amount of memory that is within the limits of what physical memory I have on this machine. I have 64 gigabytes of actual physical memory in my computer. And I'm going to say, how about we give 4 gigabytes of memory to this virtual machine? So that would be 4,096 megabytes. And there's a checkbox here I could use if I wanted to, which says use dynamic memory, which means that pretty much the 4 gig is the maximum, but it will only use what it needs. Now, I don't recommend using dynamic memory unless you have a situation where you want to have more servers than really what the physical memory on the machine is capable of handling, and have it dynamically have the machines fight for the memory that they need. But on a server virtual machine, I recommend not doing that if you can avoid it, so you can have dedicated memory for that machine. We can choose a network connection. So I have an internal or private or my actual external internet connection. So I will select that one. We can choose to create a virtual hard disk for this virtual machine, or if we have an existing one, we could choose that as well. I'll go ahead and create a new one. You'll notice it names it and puts it in an appropriate location relative to where that virtual machine is being created. And then I can choose what I want to do with installing an operating system. The most typical selection would be to install this operating system later. So I will click Next. It gets a summary and finish. And it takes a very quick moment here. It's very, very quick. You see, I now have my demo virtual server. And this now takes me to the point where I was when I first installed Windows Server. If I wanted to do it here, you just double click on it and it opens up a window for this virtual machine. Now, the one other thing I do want to show you, just because it is something that I did when I installed the Windows Server, is I'm going to right click on this virtual server and go to its settings. And I want to show you that there's a couple of things that needed to be done. The first thing I needed to do is, because I needed to install off of a DVD image, is I have to add a DVD drive. So I have my SCSI controller where I could say DVD drive and then add. And then I could select the image file to go ahead and point to the actual image file. Now, I'm not going to bother going through and doing that here. I just want to show you that that's where I can do it. Another thing that you can do once you've added that DVD drive is under firmware, you can tell it to boot off of the DVD drive as a priority and go to your hard drive next. Okay, so in that way that you're actually booting off of the DVD if the DVD has been installed. All right, so that's just an example of a couple things that you would need to do in order to get this machine truly ready to install a server operating system. Cloud computing is a term that is pretty much becoming commonplace in today's world of IT networking. More and more businesses are choosing to go to cloud computing for their server services. So, what exactly is this cloud computing that you hear about? Simply put, cloud computing is the delivery of computing services over the internet or the cloud. And they do this to offer faster innovation, flexible resources, and economies of scale. So let's talk about some of the specific benefits of cloud computing. Well, the first would be cost. Cloud computing eliminates the capital expense of buying hardware and software and setting up and running on-site data centers, the racks of servers, round-the-clock electricity for power and cooling, and in some cases, even the need for IT experts for managing the infrastructure. Those expenditures can add up real fast. Another benefit is speed. Most cloud computing services are provided self-service and on demand. So even vast amounts of computing resources can be provisioned in just a matter of minutes. And sometimes it can even be just a matter of a few mouse clicks, and you can quickly provision new resources, which really gives a business a lot of flexibility and takes the pressures off of capacity planning. How about performance? The biggest cloud computing services run on a worldwide network of secure data centers, which are regularly upgraded to the latest generation of fast and efficient computing hardware. This offers several benefits over a single corporate data center, including reduced network latency for applications and greater economies of scale. It's also very reliable. Cloud computing makes data backup, disaster recovery, and business continuity easier and less expensive because data can be mirrored at multiple redundant sites on the cloud provider's network. And I had mentioned security. Well, many cloud providers offer a broad set of policies, technologies, and controls that strengthen your security posture overall, helping protect your data, your apps, and infrastructure from potential threats. Not all clouds are the same, and not one type of cloud computing is right for everyone. Several different models, types, and services have evolved to help offer the right solution for your needs. So let's talk about the three main types of cloud computing. The first would be the public cloud. Public clouds are owned and operated by a third-party cloud service provider, which deliver their computing resources like servers and storage over the internet. Now, one example of this would be Microsoft Azure. Right? I'll just keep it in the world of Microsoft because all my demonstrations have been on Microsoft. So with the public cloud, all hardware, software, and other supporting infrastructure is owned and managed by the cloud provider. You access these services and manage your account by using a web browser. But we also have private clouds. A private cloud refers to cloud computing resources used exclusively by a single business or organization. A private cloud can be physically located on the company's on-site data center, but some companies will choose to pay a third-party service provider to host their private cloud. And the private cloud is one in which the services and infrastructure are maintained on a specific private network. So we have public and private, so you can guess what the third type would be, and that would be the hybrid cloud, which is where we combine public and private clouds brought together by technology that allows data and applications to be shared between them. So by allowing data and applications to move between private and public clouds, a hybrid cloud gives your business greater flexibility, more deployment options, and helps optimize your existing infrastructure, security, and compliance. And I will tell you that the hybrid cloud is probably the most common that we see in today's world. I will also add that there is the idea of overall hybrid cloud computing in the sense that you're not necessarily having a hybrid of private and public, but you have a hybrid of a truly private or local infrastructure that's You can see why it's becoming more and more popular. As IT administrators, stereotypically, we are looked at as being kind of control freaks, right? We got to be in total control over everything. And you know what? To some degree, we do. It's important to have control over everything. But there's one thing that you cannot control, and that is a disaster. You have no control over it. If it happens, it happens. All you can do is plan for it. All right, so let's talk about disaster planning a little bit here. Let's start off with the overall continuity of operations. So there's a few different plans that we can have in place, or documents we can have in place. First one is called a business continuity plan. This is a plan that considers all aspects that could essentially be affected by a disaster. It includes things like different functions, systems, people, facilities, or pretty much everything you could imagine in your organization. And then it also prioritizes them. Now, from there, you also want to have a disaster recovery plan, right? So you don't want to just recognize what's at stake, but also have a plan on how to recover when you lose those things. In this plan, you want to be as detailed as possible with every possible scenario of what could happen. And more importantly than that, and that's the hard part, by the way, right? Coming up with what's every possible scenario. But you also want to have very detailed steps on how to get things back up and running again. And then from there, we'll move along into a business impact analysis, which is where you take your business continuity plan and your disaster recovery plan and you put it together. You look at who is affected, what is affected, and the severity of the impact based upon a number of different scenarios that could play out. All right, so the bottom line is these disasters happen, and so you need to know how that's going to impact your business. Now let's talk about replication a little bit here, right? That's one of the ways that we can actually protect, is have some kind of redundancy or replication so that things are in more than one location. So first, we can talk about disk-to-disk replication. Or we talked about this in another video where we talked about RAID. Disk mirroring would be an example of this, right? Where everything that's written to one disk is also written to another disk. That way, if the disaster affects a specific hard drive, well, you've got it on another hard drive. And then you have server-to-server replication, or what's sometimes known as failover clustering. And this is the idea of where you will have everything that's being written to one server, and not just written, not just data, but it could also be even the services of one server are also being replicated over onto another server, so that if the disaster was to kill one of your servers, well, you have another server in place to pick up where it left off. And you could go to a full extreme, which is what's known as site-to-site replication, where you might actually have multiple locations and everything that's done in one place is also done in another place as a backup location. And it could be, and we'll talk about the sites in just a moment here, but it could be just your data that's being replicated or being stored offsite somewhere else. Or it could be that every aspect of one location is truly replicated at another location. So let's talk about these sites. We have a hot site, right? That would be the last thing I was just talking about, right? Where literally everything in one place is essentially simultaneously set up and ready to go in another place, which means even if the disaster was to completely take out a building, right, an entire location, well, hopefully the people weren't there when it happened. And so you just go ahead and you have everybody go over to the other location and business is still up and running. And then you also have what's known as a cold site. Now, this is where you can have an alternate location that really is nothing more than it's a place, right? You might have a building that's been rented, but it's mostly just vacant and ready to be built out as a new location in the event you lose your first location. And this is almost like Goldilocks and the Three Bears. Then you have the warm site, which is, this one's just right, which is somewhere in between, right? Where maybe you need something more than a cold site because you need to be able to be up and running a little bit quicker than what it would take to rebuild in a new location. But you don't want to spend the money on having an exact duplicate of everything up and running at all times in two places. So a warm site is where you just have the general infrastructure in place and ready to go. And then you would only have some detailed information that you would need to carry over to get that site fully up and running. All right. So again, remember, you can't control disasters. All you can do is plan for them. And it's very important that you do so because you don't want to lose everything because you didn't plan for a disaster you could not control. One of the most important components to any disaster recovery plan is a good backup strategy. So what I want to do with you here is I'm going to talk to you about the 3 different types of backups. Well, really there's 4. The 4th one doesn't really have to do with disaster recovery. I'll explain in a minute. But I'm going to talk about what the 3 different types of backups are and then the strategies behind using them. And I do want to tell you before I get into this, I've been teaching this for well over 20 years. And it was exactly the same back then as it is today and probably will be well into the future. What are the different types of backups? First, we have a full backup, or what some backup systems call normal backup. And the idea is all data is backed up. Doesn't matter whether it needs to be or not. It just backs up everything. And then there's what's called an archive bit, okay, which is a bit that is associated with the data that is really nothing more than it's a trigger to say whether that data has changed or not. Okay, so we're basically going to back everything up and then say everything's been backed up. Reset all the archive bits. Now, the second one I'm going to mention here, this is the one that does not have to do with disaster recovery, but I'm going to mention it just because backup systems include it. I want you to know what it is. It's what's known as a copy backup. It's just like the full backup in the sense that everything is backed up regardless of whether it's changed or not, but we're not going to reset the archive bit. And the reason is because this is not backing up for the sake of doing a backup. This is for if you're going to, let's say R&D needs a copy of the data for a project they're working on. So you send over a copy of all the data. All right, so that's what a copy backup is. Next, we have an incremental backup. So pay attention here. All data that has been changed. Okay, so it's not going to do all data like a full backup. It's going to do all data that has changed. And the archive bit is reset. All right, now I know on the screen it says since the last full or incremental, but I'll get to that in a minute. We're just going to say anything where the data has changed, back it up, reset the bit. Whereas the differential backup, very similar. You're going to do all data that has been changed. Don't worry about it says since the last full backup. I'll explain that in a minute. But all data that's been changed, but we're not going to reset the archive bit. Okay. What are the strategies here? Well, one strategy would be to do just full backups. In other words, at whatever scheduled time you feel is appropriate, depending on your organization, daily, weekly, some do it hourly. You just basically say, do a full backup. Just back up all my data and just keep copies of it. Now, here's the thing. You can imagine that by doing a full backup of everything all the time means that it's going to be lengthy to do your backups. But the upside, right? That's the downside. But the upside is recovery is the fastest, right? So it's the slowest backup, but the fastest recovery. Because if we were to ever lose data, all we have to do is go to our last full backup and boom, recover it. And then we have full/incremental backup plan. And the idea here is, and I'll just give you an example of what we might do. Once a week, we might do a full backup, and then every day during the week, we do an incremental backup. So that means that maybe on Sunday night, we just back up everything, right? Maybe business is shut down, doesn't matter, takes all night. Great, do a full backup of everything. But then each weekday, we just do a quick incremental backup of what changed that day. Right? What changed on Monday? What changed on Tuesday? What changed on Wednesday? What changed on Thursday? Okay, so that means the backup time will be very quick because you're only backing up what changed that day. The downside to this strategy is the recovery time can be very lengthy because if, I'll just again give you an example, let's say we lost data on Friday. Well, now in order to get that data back, the first thing I have to do is I have to go and restore the full backup from Sunday. Then I have to from Monday, then Tuesday, Wednesday, and Thursday, right? Because I have to get all those changes in place to then get us back to where we were. So it's a lengthier recovery process. And then we have what some people like to call that happy middle ground, where you do the same thing, where you do a full backup, let's say once a week, and then every day in between, you do a differential backup. So that means on Sunday, you do that big, long backup. And then on Monday, you do a differential, which means you're backing up whatever changed just on Monday. And then on Tuesday, you're going to do another differential backup, which means you're going to do backup whatever changed on Monday and Tuesday. And then on Wednesday, you're going to do a backup Tuesday and Wednesday. And so the idea there is that the backups are a little bit faster than doing full backups every day, but they get lengthier and lengthier each day. And then recovery is kind of a middle of the road recovery, because all I'd have to do, let's use that same example of Friday, we need to recover data. I'd have to go back to the full backup from Sunday, and then I only have to go to the last differential backup on Thursday to get me back to where I was. All right, so those are the backup strategies that have been used for a very, very long time and most likely will be used well into the future, and you just need to figure out what works for your organization. The idea of being good at troubleshooting problems with your servers and your networks is really nothing more than just being familiar with the servers and the networks and being able to recognize when something doesn't look right. So basically, I've been teaching you how to troubleshoot throughout this entire course. But beyond that, it's also very important to have a good troubleshooting methodology. So I have 5 steps here to good troubleshooting, and let's go over each one in detail. First, what are the 5 steps? You want to identify a problem, theorize a probable cause for the problem, test that theory, see if that actually was the cause of the problem. If it was, plan and implement a resolution, and then test to make sure that resolution was successful. So let's start off with identifying the problem. Step 1, question the users. Here's the thing. We get accused very often as IT administrators of being very accusatory when talking to users, right? Because we say things like, what did you do? That sounds to the user like you're saying, what did you do to break my system? What did you do? It's your fault. So you want to be careful about how you word your questions to the users. Say things maybe more like, so what is it that you were doing? Or what were you trying to accomplish? Or what do you normally do? And so on and so forth. Again, it's a very fine line, but you want to be careful. You want to identify anything that has recently changed. You may want to even just check the logs, see if the problem can be found in there, or maybe even try to replicate it. So if there's a problem over on one server, maybe you go over to a test server, try to see if you can replicate the problem. Now, once you have identified the problem that you have, you want to look for a probable cause. So the first thing is you want to look for common elements. So this is the idea of, if something is happening, where is it happening? Is it happening just to an individual system? Is it happening to an individual person? Is it happening to an individual network? Where is the consistency? When I say individual, maybe it's the opposite. Is it happening to all people? And if it is it all people in a certain group? Things like that. Now, another thing, this is called keep it simple, really KISS, the KISS method, keep it simple, stupid, is start with the obvious. We as IT administrators, we tend to want to be the hero. And so we tend to be alarmists. We think, oh, this is the big one. No. Look for the obvious first. Then if none of those obvious causes are it, then you can move to the less than obvious cause. But really, the most obvious cause is usually the right one. So once you have a probable cause, you want to test it and see if that is right. So you want to determine what steps you would use to resolve if that was the right cause. And if it turns out that your theory is wrong, well, then go back and try a new theory. Now, as far as planning your resolution, first of all, determine if escalation is necessary. This is another big problem. Everyone wants to be the hero, right? I will solve it. I will solve it. I will solve it. No, you need to determine right away, is this within the realm of what you can do to solve it, or do you need to escalate? Because if it needs to be escalated, then you doing your job properly would be to escalate it. It is strongly recommended that, if possible, that you perform backups before implementing any plan, because you could break something as part of your plan. And you want to make sure to notify any users who may be impacted by the changes you are about to make. Once you have planned out that resolution process, now you can actually implement the resolution. First thing is, make one change at a time. And you want to confirm the results of that change. If that change didn't give you the results you were expecting or fix the problem, don't go and try something else. First, reverse that change and then try something else. Okay, because that's another big problem that people have is they'll try something, say, nope, that didn't work. Something else, nope, that didn't work. Something else, nope, that didn't work. Something else. And then they've changed so many things, they're like, oh, great. Now I've really messed up the system. And then finally, the last piece would be to verify the success. Check the system, make sure that it's up and running. Check with your users who were impacted, make sure that they are all fine. And I don't mean just the users who were complaining about the problem, anybody who may have been impacted by the changes you're making. And when you're checking with those users, make sure that no other problems have been created as part of you fixing the other problem. And then the last step, which is not really part of the actual troubleshooting, but it's kind of an afterthought, is to analyze everything. You want to perform a root cause analysis to see what it was that caused this problem in the first place. And if possible, put preventative measures in place so it doesn't happen again. And then the most important thing I can put out there, which is document, and document. Because every time there's a problem, we think to ourselves, oh, okay, I'll remember that the next time it happens. Well, first of all, it may not be you, it might be somebody else. So it'd be nice if there was documentation in place, make life easy for the next person. And or even if it's you, but now it's been 3 years since this problem happened and you're like, oh, I remember I had that problem. What did I do to fix it again? Yeah. Having good documentation is very, very important. All right. And so that is really the right methodology that you should be using for good troubleshooting techniques.